Okay, we're going to start by talking about, no, we're not going to start, we're going to finish actually, which is kind of funny to say. We're going to finish by talking about something called L'Hopital's rule, which literally translates into the hospital. That's a guy's name. The guy's last name was the hospital. I'm sorry?
You know what his ancestors did.
Yeah. Well, I don't know. They could have been doctors, nurses, janitors.
Maybe they cooked.
They worked in a hospital. Or they built hospitals.
Right.
Or they were.
Or they were all
people.
Or they were a hospital.
They were just like in the lived in.
Or they could have been hospitable.
Yeah, that's
That's
true.
Kind of sounds like a hospital. Anyways, in the past, this has never been a Calc AB topic. It's always been something we've done at the end because it's a useful tool. Starting next year, this becomes a Calc AB topic that's on the syllabus for Calc AB. Doesn't apply to you, but it's still a very useful tool. So what it allows you to do is we're going to go all the way back to limits again, and we're going to start looking at what happens when we get a limit that doesn't work out well. And so what we've done already, just a quick review, what's the first thing you always do with a limit?
Plug and chug.
Plug and chug. And then we found, well, if that plug and chug doesn't work out, we have to do a couple, we have options to do a couple different things. Those things were factoring, algebraic manipulation, cry, plug and chug again. You know, you got a whole bunch of different options here. L'Hopital's allows you to take it a step further using a more algorithmic approach for certain things that are called indeterminate forms, and I'll show you a couple indeterminate forms in a second. Okay. This is all the fancy calculus speak, but it's really simple. If you want to take the limit of some function, that's a combination of functions, one over the other, f of x over g of x, and you run into an indeterminate form. So the indeterminate forms we're going to look at today are 0 over 0 and infinity over infinity. If it turns out to be one of those two things, then L'Hopital discovered, well, instead of doing the limit of f of x over g of x, I can just take the limit of f prime of x over g prime of x. And it works out to be the same answer. Common mistake that people make with L'Hopital's is they take the derivative of f of x over g of x. This isn't quotient rule. It's just the derivative of the numerator over the derivative of the denominator. The result you get from that problem is the exact same limit that you would get if you were able to do this somehow, the first part. Make sense? Okay, let's not make this more difficult than it has to be. I've got about 4 or 5 examples to take you through and show you how this works. It's pretty straightforward.
Can you go back?
Aside from the mistake of doing the derivative as a quotient rule, the derivative of f of x over g of x, the other mistake is people don't check to see if it's an indeterminate form. You have to verify the fact that it's an indeterminate form first before you apply L'Hopital's. You good? Okay, so here's my function. The rules still apply. What's the first thing you do with any limit problem? Plug and chug. So what happens when we plug 0 into that function? We get 0 in the denominator. What's the numerator? Okay, and this is important because just getting 0 in the denominator isn't enough for us, because then we can go back to the old rules and just start algebraically manipulating it, see if we can factor out an x, do all this other garbage.
It's also 0.
Yeah, the numerator is also 0. Okay, we've now verified that it's an indeterminate form. So now L'Hopital's applies. If it's not 0 over 0, if you get a number over 0, then this doesn't work. Okay, you with me so far? That's the setup.
Wait, so it has to be 0 over 0 or infinity?
Infinity over infinity.
Okay.
Yeah, there's others, but we're going to just do those 2 today. We'll do more tomorrow. Okay, so now we can apply L'Hopital's. That's weird. Okay, what's the derivative of the numerator? The denominator? 2. Now what? Plug and chug. What's the sign of 0? 0, so therefore the limit is 5 halves. All done.
So is the limit
So it wouldn't have helped you much in the beginning because we didn't run into a lot of indeterminate form. We ran into a lot of blah, blah, blah over 0, blah, blah, blah over infinity, that kind of stuff. Question?
So that means the limit of the first one is also 5 halves?
Yep, yep. Also notice my notation. You have to continue to write the limit as x approaches yada, 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 until you actually take the limit, then you just write the answer. Okay. Do this one on your own. At least the plug and chug part. What's e to the 0 again?
1.
Good. What do we have?
0.
E to the 0 is 1. 1 plus 1 minus 2 is 0. The cosine of 0 is 1. 1 minus 1 is 0, so we have an indeterminate form. Now apply L'Hopital's. What's a derivative of e to the 3x?
3 times e to the 3x.
Good. 3 times e to the 3x. And the derivative of e to the negative 3x?
Minus 3
Minus 3 times
e to the negative 3x.
e to the negative 3x. Derivative of negative 2? 0. Derivative of 1? 0. Derivative of the opposite of cosine of 5x? 5 sine of 5x. Now what? Plug and chug. What happens? 0 over 0. Uh-oh.
Do it again.
Do it again?
L'Hopital's proof.
All right, let's try it again. We're all in agreement it's 0 over 0, right?
Yep.
Okay, let's try it again. I hope this works. Derivative of 3e to the 3x. 9e to the 3x. The derivative of negative 3e to the negative 3x.
Plus 9 e
Plus 9e
to the negative 3x.
to the negative 3x. Derivative of 5 sine of 5x.
25. Negative 25.
Negative or positive?
Positive.
Positive 25 cosine 5x.
That didn't help.
Okay, so the top is,
The problem is just, maybe you.
oh,
made
wait a second, the top is 18.
Yeah, yeah.
That's good.
It's 18 over 25.
And the cosine of 0 is 1, so 18 over, oh. So what if you apply L'Hopital's rule and you get another indeterminate form? What did we just learn?
Do it
Keep
again.
going.
Do it again. And then if you get another indeterminate form,
Do it
Keep
again.
going.
do it again. And just keep going. And hopefully, eventually, we'll get to something that makes sense. It is possible that you could just keep going and going and going, and you just keep getting 0 over 0 over 0. That's not very common, but it does happen occasionally.
Yeah, give us something that's like 12 of them.
What do you got, a death wish?
I would fund
Okay, so now I changed the thing that we're approaching, which means we get a different form here. We're calling what the graph of the natural log looks like. What's the natural log of infinity? What happens to the natural log graph as you go very far away from the origin?
Asymptotes.
It goes to infinity, right? If you'll recall, the natural log graph curves up.
It's close.
So the top is going to be infinity. What's the square root of infinity? Infinity. Indeterminate form. That's our second. Now we're good. Okay, time to jumpstart your noodles here. What's the derivative of the natural log of x?
1 over x.
Good. And what's the derivative of the square root of x?
Isn't it?
No. 2x to the 1 half.
1 half,
1 half
x to the negative 1 half. 1 half x.
1/2 x to the negative
1/2 x to the negative 1/2. 1/2 x to the negative 1/2.
Yeah.
Okay. Which, before I plug and chug again, I'm going to rewrite this to make it a little bit easier to see. This is 1 over x times 1 over 2 square roots of x. Right?
Yes.
Which is the same thing as the limit as x approaches infinity of what happens when you divide by a fraction? Multiply by the reciprocal, so 2 square roots of x over x. Well, should I just plug and chug now, or can we simplify that more?
Square root.
What's the square root of x over x?
Next.
Root x.
1 over root x.
Why, cos? Why are you smiling at me? Did you just guess?
No, maybe. No. Because root x squared is x.
Could you do
Sounds good.
Wow. Lucas.
We divide the top and bottom by square root of x.
Yeah, this is x to the 1/2. You divide, or you subtract the exponents. 1/2 minus 1 is negative 1/2, which brings it back to the bottom over here. Okay. So that would then become the limit as x approaches infinity of 1 over the square root of x.
Two.
Huh?
Two.
What? Oh yeah, you're right. There's a 2 in there. Good catch. Okay, now what happens when you put in infinity? 2 over infinity. What's 2 over infinity?
0.
0. Okay. Does everybody understand why? If the denominator of a fraction gets very big, the fraction gets very small. If the denominator of a fraction gets very small, the fraction gets very big. That's not, the point being, that's not an indeterminate form. That's not 0 over 0 or infinity over infinity. That's just some weird limit stuff that we did a long time ago. What happens when what's 2 over infinity equal to? It's equal to 0. Okay, having fun yet? L'Hopital's got us to here. The rest of that is all algebra. And you didn't have to do the algebra. You could have just plugged and chugged infinity in there. It would get a little ugly though. You get 1 over infinity over 1 over 2 times infinity, which then you have to figure out how to simplify. So it works a little bit better if you do the algebra in the front end. Okay. Go ahead. Excuse me. Sorry. What's the graph of e to the 3x look like? More importantly, what's e to the infinity power? Infinity. What's infinity squared? Infinity. So?
Infinity over infinity. There's never a word for that.
Okay, go ahead, apply L'Hopital's rule.
Until the Hawks got
Because like you plug in infinity, when you it's literally e to the 3x, you plug in infinity, it's infinity over to infinity. It's like it just. It's so
Okay, what do you get?
Infinity.
Infinity. Infinity over 2, which is?
Infinity.
Infinity. Take the derivative of the top, which is, by now we've done that enough, e to the 3x, 3e to the 3x, 2x. Plug and chug, what do you get? Infinity over infinity again. Apply it again. 9e to the 3x over 2. Ooh, plug and chug, infinity over 2, which is just infinity. Okay, good. Any problems?
What if it, like, oh, never mind. Because I was like, if it was 0, but then you would have put the 2x.
Right. Yeah, we would have kept going, and we get some ugliness there. Okay, I think I got one more for you. Try that one. By now, we've done enough e to the x things that you should be able to take the derivative of e to the x and e to the negative x easily. You're right. I'm making an assumption. My assumption might be wrong. Thank you for bringing me back to earth, Max. Okay, let's see how many people I suckered into this one. What's the derivative of e to the x? E to the x. What's the derivative of e to the negative x?
Negative e.
What's the derivative of x squared? 2x. Plug and chug. 1 minus 1 is 0 over 0 is an indeterminate form. So then we do it again. E to the x plus e to the negative x over 2, which is, that's 1 plus 1 is 2, 2 over 2, which equals 1. Why are you shaking your heads at me? What?
Don't you just plug in your
Plug and chug.
Oh. Really?
Well, yeah,
Yeah,
yes,
so
yes.
over
I'm
0.
positive that's what you.
I just applied L'Hopital.
Plug and chug.
Well, you
But it's not indeterminate.
Jug and tug.
What?
Just read it, it's not indeterminate.
Shut up.
Yeah.
Really?
Yeah.
I should have checked that. Oh, darn. What's the first thing you do for every limit?
Plug and chug.
Plug and chug. What didn't I do?
Plug and chug.
Plug and chug. What happens when you plug and chug? You get what?
2 over 0.
Uh-oh. That's not an indeterminate form.
So we're done.
So you're done. Well, not yet. What's 2 over 0?
Yeah, it does not exist. Undefined. Undefined.
It's a limit. What happens as the denominator gets very small?
Number gets very big.
It's infinity. The point being, this is invalid because we never checked to make sure that we have an indeterminate form. You have to check the limits to make sure that they're an indeterminate form. Just don't take any limit and start L'Hopitaling it because you're going to run into some problems. That's the reason we did this example. Okay. Tomorrow, we'll talk about some other indeterminate forms. There's a 0 to infinity. There's a infinity minus infinity. But this will get you started on most of them. So the two indeterminate forms we have so far are infinity over infinity and 0 over 0. Okay, don't assume that every problem you do tonight is a L'Hopital. You got to check it first. Okay? We'll go over that tomorrow along with nothing else. And then I'll teach you the other forms tomorrow. We'll review on Wednesday and then quiz on Thursday and then fun.
Do you have the sheet with this day one?
Yeah, it's on